Okay, co-function identities. Now, if you look at these identities, you can see that they all deal with pi over 2 minus x. So we have our sine is cosine of pi over 2 minus x. Cosine is sine of pi over 2 minus x. Tangent, cotangent, secant, and cosecant. So they go together with their cos, right? All right. Obviously, the word co-function identities, all right? So we're going to use those facts, and those should make sense to you, because if you think about on the unit circle for a second, if you think about the sine of pi over 3, okay? If I take pi over 2 and subtract pi over 3, I get pi over 6, okay? Or if we think about it with 90 degrees, okay, instead of pi, 90 degrees for a second. So if I said that, that this was the cosine of 90 minus x, all right? Well, the sine of 60 is square root of 3 over 2, right? Okay. And if I do 90 minus 60, I get 30. And the cosine of 30 is square root of 3 over 2. So these all work in that sense. Right? Now you can do two things. Right? We're going to go talk about these co-functions, but if you really wanted to, you could just use the difference identities for that function to find that answer. You wouldn't have to use the co-function. Okay? So they want us to verify that the cosine of x minus pi over 2 divided by the cosine of x equals the tangent of x. Now, if we're talking about co-function identities, this is backwards. This says x minus pi over 2, not pi over 2 minus x. So what we can do is think of it as here, that the x minus pi over 2 is equal to the negative of pi over 2 minus x. So then it becomes, so then we're looking at the cosine of a negative angle. Well, what's the cosine of negative x? Cosine of x. Look at that, nice arrows. That's just equal to the cosine of x. Right? So we can, so what we're going to have to do is look at the fact that it's the opposite. So cosine of x minus pi over 2 is the same as the cosine of negative pi over 2 minus x. Right? Divided by the cosine of x. So then, let's see, the cosine of a negative angle is just the cosine of that angle. So this equals the cosine of pi over 2 minus x. Cosine of x. All right. But this is a cofunction identity. Cosine of pi over 2 minus x is equal to sine of x. So here we have sine of x over cosine of x, which does equal tangent. Okay. And like the little note I have here, okay, you could also just use a difference identity for cosine to simplify it. Right? And probably you get into the heart of a question, and more than likely you're probably going to end up doing that. Okay, just because you see that, say, oh, okay, that's a difference identity, I'm just going to use a difference identity. Okay? But if you get to the pi, get a pi over 2 minus x, or x minus pi over 2, you can always use the cofunction identities. Okay? So here we have, for number 6, they want us to verify that the sine of x minus pi over 2 over cosine of x is equal to negative 1. So we look at this and, hey, that says the sine of x minus pi over 2. It does not say pi over 2 minus x. Okay, it's not that. So that means then I have to do the opposite of x minus pi over 2 to be able to get that. Okay? Okay. So if we do the sine of a negative pi over 2 minus x, right? And what is the identity for negative sine? Sine of negative x equals what? Sine of negative x is equal to negative sine of x. Okay? So that means then this is negative sine of pi over 2 minus x over cosine of x. Well, what's the this is the cofunction. Sine of pi over 2 minus x is equal to cosine of x. So negative 1 equals negative 1. Okay. Here's number 25. It says if sine of x equals 1/3 and x is between 0 and pi over 2, so the first quadrant, then the sine of pi over 4 plus x is equal to 1. So if we use our sum identity for sine, we'll have the sine of pi over 4 cosine of x plus cosine of pi over 4 sine of x. All right, there's our sum identity. Well, we know what sine and cosine of pi over 4 are, right? We've done that lots of times. But what about the cosine of x and sine of x? They tell us what sine of x is. Okay, that's great. That's 1/3. So I can put 1/3 here. But I don't know what cosine of x is, do I? Can I figure it out? And the point is I can, because I have a triangle in the first quadrant. If sine is 1/3, the opposite is 1. The hypotenuse is 3. And then the adjacent side would be what? Square root of what? Square root of 8, right? Because 1 squared plus x squared equals 3 squared. So x squared would equal 8. So that means this is 2 square roots of 2, right? So sine of pi over 4, square root of 2 over 2. Cosine of x is 2 square roots of 2 over 3. Cosine of pi over 4, square root of 2 over 2. So then it's just a matter of doing that multiplication. Didn't give myself an effort. Get down there. So we've got, what's the square root of 2 times 2 square roots of 2? 4, Chris? Okay. All right, so we have 4 plus square root of 2 times 1 is square root of 2 over 6. Okay. All right, and we can leave it that way. So there's our answer to number 25. 4 plus square root of 2 over 6. But the reason I wanted to do these couple extra is just to go back through using the triangles, okay, to find them out. All right, so let's look at number 34 here. We're going to do this. All right. Number 34 says, assume that sine of x equals 0.8. Sine of y is square root of 0.75. And that x and y lie between 0 and pi over 2. Evaluate the given expressions. So we're going to find the tangent of x minus y. and given that information. Okay. So, tangent of x minus y is the tangent of, is equal to the tangent of x minus tangent of y divided by 1 plus the tangent of x times the tangent of y. Okay. There's our difference identity for tangent. Well, what does tangent of x equal? And what does tangent of y equal? How do I find them? Okay. Same situation. First of all, they tell us that we're in the first quadrant. Okay. So I'm going to have to make two triangles. Both of them are in the first quadrant. So I'm going to have to do two separate triangles to help me out here, so that because they're both in the first quadrant then, so I got to do them separate things. So first of all, we'll do angle x. All right, here's angle x here. It says sine of x is equal to 0.8. So that would be opposite over hypotenuse, 0.8 over 1, right? So what would, so you said 4/5? Okay, we could do decimals or we could do fractions. It's up to you. Okay. But can I square 0.8? What do I get when I square 0.8? What's 8 squared? So 0.8 squared is 0.64. Okay. So we would have 1 squared minus 0.8 squared, which equals what? All right, we're using the Pythagorean theorem here. All right, 0.36, right? And what's the square root of 0.36? 0.6. All right, so our x is 0.6 here. All right, you okay with that, Ben? Okay. All right, now it says our angle y is also in the first quadrant. So that's here. And it says angle y, the sine of y is square root of 0.75. I don't know if I can get that in there. Square root, no, we can't. We're going to move it. Right? Square root of 0.75 over 1, right? Okay, so what's the adjacent side then? Or what's x? This is angle y. What'd you get? Okay. Is it 1/4 or is it the square root of 1/4? Okay. So this is the square root of 0.25. Okay, we all good there then? Those numbers, Michaela, you all right with them? Okay. So we're going to use our tangent then. So tangent of x, 0.8 over 0.6. Minus tangent of y, square root of 0.75 over the square root of 0.25. Oh, this is going to be lovely. Okay. And 1 plus those numbers. So this might be a situation where you might want to use cosine and sine, right? Just because those things are so not pretty. But you know what? They're all decimals, right? So if I'm thinking correctly then, I'll just use decimals for all my work. I'll find the answer for the numerator. So let's see, I don't have my calculator up. But the answer for the numerator You know, that's really, it's 4/3 minus square root of 3. Okay, are you with me? Okay, because I can, since I'm dividing here, I can make it one radical. And over 1 plus that product of 4/3 times the square root of 3. Okay. Oh, that makes it a lot simpler now then, doesn't it? That looks easier. Okay, that's something I can easily type in my calculator and find the answer for. Okay, and what is the answer then? I'll take a decimal in this case. Okay, negative 0.120. But the whole point is utilizing our quadrants, knowing that here's the triangle I need. I need this triangle here for angle x. I need this triangle here for angle y. Okay. So you can find sine, cosine, and tangent. Now, how many of you wrote these two triangles down? Anybody write them down? Guess what? Part of your assignment is some of those other ones, 29 to 34. In 29 through 34, they all use the same triangles. Okay? So you might want to write them down. Yeah. Like example 4, I think it was, or 5. I guess it was 5, example 5. Okay? All right, so it says if x is in the first quadrant, y is in the second quadrant. Sine of x equals 24 over 25. Sine of y equals 4/5. Find the exact value of the addition identity for sine and the addition identity for tangent. And tell me which quadrant does x plus y lie in. So what's the first thing I need to do? Grant, what do you think? What's the first thing I should do? Draw the triangles, exactly, okay? Here's the thing. Whenever they give you information that's not on a unit circle, the very first thing you should do is draw triangles so that you have all of the information you could possibly need. Okay? So we're going to draw the triangles first. Well, the nice thing about this is that one of them's in the first quadrant, one's in the second, right? Okay, so go ahead, draw the triangles. You draw them on your paper. I'll draw them on mine. And fill in the important information. Let's see, let's go. Okay, so we have the triangles done. How come I put -3 there? Okay, because we're on the left side, right? X is negative over there. Okay, how many of you didn't put a negative there? Okay, all right, you got to remember that. Which quadrant am I in? X is negative in the second quadrant, so I have to put the horizontal part negative. Now, let me ask you this. All right, I have an angle in the first quadrant and an angle in the second quadrant. Right? And so when we're all done, okay, they want to know which quadrant does the sum of them lie in. So what are my possibilities? Could x plus y be in the first quadrant? I'm going to throw some numbers up here. Let's see here. Let's put, if I have 0 here in first quadrant, that would be 90, right? Here's 180, 270. Okay, so 1, 2, 3, and 4. If I take a number between 0 and 90 and add it to a number between 90 and 180, can I get a number between 0 and 90? Can't, can we? All right, so the answer cannot be in the first quadrant. Okay? All right, so if I take a number between 0 and 90 and a number between 90 and 180, can I get a number in the second quadrant? Okay. If I had 95 plus 20, it would be less than 180, wouldn't it? Okay, so my answer could be in the second quadrant. Right? So in the second quadrant, sine is positive and tangent is negative, right? Okay. Could I end up with an angle in the third quadrant? I could, right? I could have 150 and 60. That would give me 210, which that's in the third quadrant. So in the third quadrant, sine is negative, tangent's positive. Right? So could I get something in the fourth quadrant then? Well, if I had 179 and 89, would those get me to the third quadrant? Those are the two biggest angles I could have. No, because if I add them together, I get 268. Right? So my answer is either going to be in the second quadrant or the third quadrant when I want to know where does that sum lie. Okay. Now, let's think a little bit further. Okay? Let's actually think about our triangles for a second. Are my triangles realistic? So really, my triangles, if I was to draw them more appropriately, because I just drew true triangles, that in the first quadrant, it should actually be closer to something like this, right? 24, 7, and 25, right? Okay. And in the second quadrant, then, it's probably going to be a little bit closer to something like this. Right? So it's possible I could get to the third quadrant. More than likely, I'm probably going to end up in a second, aren't I? Okay, so let's see what happens. All right, so we want the sine of x plus y. So that's sine of x, cosine of y, plus cosine of x, sine of y. So let's see, sine of x, 24 over 25. Cosine of y is negative 3/5. Cosine of x, 7 over 25. And sine of y is 4/5. Right. So this gives me negative 72 plus 28 over 125, right? Which is negative what? Okay, I'll help you out. 44 over 125. All right, it's negative 44 over 125, and that's what the sine of x plus y equals. All right, so I already know which quadrant my answer lies, don't I? Since sine is negative, it's either got to be in the third or the fourth, doesn't it? Okay, and we've already figured out it can't be in the fourth because my angles can't be big enough to get there. Okay? So my answer is going to end up in the third quadrant. So when I find tangent, tangent better be what? Positive. Okay. So now to do the tangent part, you have two choices. You could find cosine and then just do sine divided by cosine if you wanted to, in which these numbers are easy enough to do that. Or you could do the one with tangent. Okay? So I'm going to stop there. Okay? What, you want me to finish it? Okay, you guys good? Okay. But the biggest thing with all of this is utilizing the triangles.